Imagine this, your project is due in just 3 weeks. You describe the idea to AI, it writes the code, it fixes the bugs, it even helps you draft a report, and the project runs. And then comes your project viva. Your guide looks at the screen and asks one question. Why did you choose this approach instead of a simpler one? And your mind goes blank. Not because you're not capable, but because you never made that decision. AI did. And your major project probably is not the only place where this is happening. It might be happening in your placement prep too. Your DSA practice, your mock coding rounds, the project explanations you're rehearsing for interviews right now. You're perhaps a few months walking into a real job, maybe even less. And if AI has been doing most of your thinking as a final year student, then are you really an industry ready engineer? And when the problems get bigger, like the first challenges that you're going to face in a real software company, do you think AI will be able to bail you out there too? Yes, AI can finish your college work in minutes today, but is that really a smart move? Okay, this is not an anti-AI video. We are not asking you to not use AI. You just need to know how to use it so that it doesn't affect your software engineering abilities. In this video, you will learn the 10-3-1 ownership rule, a research-backed method to use AI while studying computer science engineering so that AI doesn't end up doing the thinking that's supposed to help you with your career. And here's the part that most final year students get completely wrong. An AI answer can be completely correct on your screen. You may even read it quickly and feel like you've understood it fully. But if you don't spend enough time understanding the problem deeply and arriving at the solution yourself, you may run into bigger problems later on. So, how does this gap really show up? One of the ways it shows up is when the questions change slightly. The code makes sense when AI is explaining it, but then close the screen and change one condition of the problem and suddenly all the understanding is gone. People call it the AI skill debt. You might save time today, but you're borrowing understanding from your future self. And that debt comes due later, in a project defense, a placement interview, or on your first real job when there is no AI tab open and someone is waiting for your answer. See, AI can genuinely make you faster, and that part is real. In a controlled experiment, researchers recruited 95 professional programmers and asked them to build an HTTP server in JavaScript. The group with access to GitHub Copilot completed the task 55.8% faster than the control group. That's a real measured result. Professional developers already experience working on a standardized task. But then here's what it means for an engineering student. So yes, AI makes modern software engineering faster, but that's especially true when the engineer exactly knows what's required and how the code is to be built. But as a student, using AI to jump straight to the final answer without understanding how the project works is not the best way to develop yourself into a future software engineer. So speed is real and useful. But the real question is what happens if speed quietly replaces practice? A 2025 Microsoft research study surveyed 319 knowledge workers and collected 936 real examples of people using generative AI at work. The finding worth sitting with. Greater confidence in AI's ability to complete a task was linked to less reported critical thinking during that task. See, this was self-reported, so it doesn't necessarily prove that AI damages your thinking abilities or anything like that. But it does hand students an honest warning. The more convincing an answer looks, the more easier to stop checking your own understanding of it. But that doesn't mean stop using AI. It only means that AI should not necessarily get the first turn. Researchers also deployed AI teaching assistants in an introductory programming course and studied feedback from 813 students. Students preferred support that protected their independence, like hints, questions, step-by-step nudges, over being showed the finished solution outright. And that's the actual difference between an AI tutor and an AI answer key. An AI tutor might be slightly slow in the short term, but it actually helps you learn to be a better master of your decisions in the long term. An answer key does the opposite. It gives you outright solutions in the short term very quickly, but then it affects your understanding of the problem, which impacts you in the long run. But then how do you practically keep AI in the tutor seat when there are multiple projects and placement rounds running all at the same time? Use this 10-3-1 ownership rule. First 10 minutes without AI. Define what the problem is actually asking. Define what a working answer would actually look like. Try one small example by hand and write the roughest version of your approach, even if it is incomplete. Let's take an example of a project decision like choosing a database or an architecture. Write down your own reasoning in 3 lines before asking AI for the solution. For a theory answer also, you can do the same thing. Your 3 lines first before asking the AI to react on it. Your first attempt does not have to be right. It only needs to show you what you actually understand and where exactly do you get stuck. Before you ask AI for anything, give it the full context, the problem statement, your constraints, and what you have already tried. Just don't open with give me the complete answer. Ask instead, don't solve this yet, which concept am I missing? Then ask me 2 questions that would help me find the flaw in my approach. And then give me one edge case that would break this. For your project, for instance, ask AI to challenge your design choice before even writing a single line of code through. Ask it what would break and what you are not accounting for. And in the third step, close AI completely. For a DSA problem, explain your approach out loud, state the time and space complexity, and write the core logic again from scratch. For your major project, pick one module and explain without notes why you built it that way and what happens if a key input is missing or wrong. For a theory answer, rewrite the core idea in 5 lines from memory. If you can't do it yet, open AI, but ask it for a hint, not the complete answer. The goal is not to prove that you never need help from AI. The goal is to make sure that the learning sticks with you for situations where no help from AI can be available, like an interview situation. Okay, but then every single time I use AI, do I have to use this 10-3-1 process? No, you can use AI for end-to-end solutions and also for regular work where the skills are outside the main domain that you're trying to build. For example, let it fix your grammar, format your notes, generate extra test cases, explain an error message, compare 2 approaches after you have already tried one, or create another practice problem. But never outsource these 3 things: your first attempt, your final explanation, and your closed screen recall. GitHub's own responsible use guidance says Copilot chat can generate code that looks valid but can be incorrect, incomplete, or different from what you actually intended, and tells developers to review and test what it produces because the security risk is unreviewed code. So AI gave me this can never be the reason why your project or your answer becomes valid. What actually makes it valid is very simple. Did you test it? Can you explain it? And was the decision behind it actually yours? So with everyone using the same AI tools, what actually makes one final year student stand out from the rest? Okay, it's not the one who refuses every AI tool and insists on doing it themselves. It's also not the one who uses AI to build a complete solution either. The student who stands out can read an unfamiliar problem, choose an approach, trace a logic, and spot a wrong assumption and fix it and explain why it works. That's what a viva panel checks for, and during placements, that's what a technical interview checks for. At Kalvium, the same principle is built right into our students' learning experience. We have a coding practice platform called the Dojo where AI checks don't just mark your code right or wrong. They push you toward a better time and space complexity or a better approach before you're allowed to move on to the next problem. It's guidance, not a finished answer from day one.
India's only Gen AI powered BTech CSE. No more boring lectures. Top executives from tech companies have come together to craft a BTech CSE where 80% of your time is spent on practical learning starting from day one, and paid internship opportunities in top tech companies before you graduate. India's only industry driven BTech CSE now available at 25 NAC A+ universities across the country.
That's why at college, every assignment, every lab exercise, every project module should end up you owning it, not just submitting it. See, using AI is not the problem. Using it without any recall, testing, or explanation is. So, to summarize, before you submit anything AI helped you with, ask yourself these 4 things. Can I explain it without the screen? Can I solve a small variation of it? Can I find an edge case in it myself? And can I rewrite the important part from memory? If the answer is yes, then AI sped up your learning. Otherwise, it only sped up your submission. So which of these 3 things are you outsourcing to AI the most? Your major project's design decisions, your DSA practice, or your interview answers? Tell me in the comments below. And even when you use AI to get the final answer, make sure that you also make your brain learn that answer so that it can get to it even when the AI is switched off. If you found the 10-3-1 approach to AI useful, hit the like button, hit the subscribe button, and tap the bell icon so that you don't miss any other video from Kalvium. All the best.